Hello all, we are discussing earth pressure, myself Janel Popat. This is video part 3. In previous two videos, we have seen basic understanding of chapter earth pressure like active earth pressure, passive earth pressure and earth pressure at rest. As well as we have seen Rankine's theory for active earth pressure in cohesion less soil like sand and gravels. Now, in that we have seen two cases. First case which is normal, second one is with submerged. And let us move forward to third case which is active earth pressure in cohesionless soil with backfill with uniform surcharge. Now, surcharge comes into picture. Let us see the figure. Here H height is of retaining wall. These pressure diagrams is backfill with surcharge. Now let us focus on this diagram only right now. Then we will move to second diagram. So in the first diagram you can see green arrows which is showing Q, which is uniform surcharge. Now in the case of uniform surcharge, there will be uniform pressure throughout the soil height. So total pressure will be K into Q plus K into gamma into H. This is due to surcharge, this rectangle is due to surcharge and this triangle is due to backfill. So now this is the case. If the soil is having surcharge height or height of the surcharge soil, which is ZE, or let us define that height as a Z, then the pressure diagram will be like this. In the second diagram you can see that here these blue lines are showing pressure diagram. Now K in bracket ZE plus H into gamma. Now K is due to active earth pressure, gamma is due to unit weight of that earth, and ZE plus H. So H is height of retaining wall and ZE is what? Height of surcharge soil. So total will be like this. Now if I want to calculate some equivalent height, which is ZE in the case of uniform surcharge, then I can compare both the pressure due to uniform surcharge in the first diagram and in the second diagram. So in the first diagram we have taken K into Q, and in the second diagram we have taken K into gamma into ZE. This is very simple. Up to this height the pressure will be K into gamma into ZE, which is very much self-explainable. Now K into gamma ZE is equal to K into Q. We can find out ZE from that, and ZE equivalent height of surcharge will be Q by gamma. So this formula can be asked in problems. Let us understand and discuss one problem here. Problem number 3. A retaining wall of height 8 meter has a horizontal sandy soil which is having properties like C is equal to 0, phi is equal to 30 degree and gamma T is 18 kilonewton per meter cube. So these are the properties of the soil. A surcharge of 50 kilopascal is acting over the backfill. Draw active earth pressure distribution and calculate total active thrust on the wall. So it is very simple. It is a case we have recently studied. So surcharge is there as well as backfill is there. So let us write given data first, then we will draw a diagram, then we will move to numerical calculations. Here given data is H is equal to 8 meter, gamma 18 kilonewton per meter cube, Q 50 kilonewton per meter square, and phi, that is 30 degree. So let us draw a diagram for that. Suppose this is my retaining wall. Here backfill and surcharge both are there. So due to surcharge there will be a rectangular pressure, and because it is uniform, and in the backfill there will be a triangular. So rectangle plus triangle will show pressure diagram for this. Now values of these triangles will be governed by K into Q for uniform surcharge and K gamma into H, that will be for backfill. as we have studied in previous cases only. Now let us write Ka first, as phi is given as 30. So Ka will be 0.333. You can also take 1 by 3. Now first case for uniform surcharge. So P1, let us say P1 as pressure due to surcharge. P1 will be like P1 is equal to Ka into Q. K we got that, Q is given, so I can get P1, first P1 pressure, that is 16.5 kilonewton per meter square, which will be throughout the height of the retaining wall. Now if we calculate pressure force, so P1 force will be, which is written by capital P1 is equal to 16.65, which is pressure, and into 8, that is height of the retaining wall, as it is a rectangle, so we have to take pressure is equal to base into height only. So it is coming out as 133.2 kilonewton per meter, and it will act at where? CG of the rectangle, and CG of the rectangle will be half of the height, so 8 by 2 will be 4 meter from base. So this is first clear idea of uniform surcharge. This red arrow is showing uniform pressure by surcharge. Now let us talk about item number 2, pressure due to backfill. It is very simple that P2 will be K into gamma into H. K is given, gamma and H are there. So writing all the values, I am getting P2 pressure 2 as 47.95 kilonewton per meter square. Converting into pressure force, P2 force, which is capital P2. Now it is in a triangular form, so I'll write area of the triangle. So 1/2 height into base, 1/2 into H, that is 8 meter, into base, that is pressure, that is 47.95. The value is coming out as 191.8 kilonewton per meter. Now where will it act? It will act at H by 3 from the base. So 8 by 3 will be 2.67 from the base. So first force, P1 force by red arrow is clear. Now second force by green arrow, P2, is also clear. So if we see throughout, total pressure will be P1 plus P2, total pressure force will be 325 kilonewton per meter. So this long blue arrow is showing total pressure, and where it will act? So total pressure force will act at both the height average, where Z bar is equal to 133.2 into 4. What is 133.2? Which is pressure given by first item, P1. And what is 4? It is the point at from base which it is acting. And same way for P2 will be 191.8 into 2.67. So taking average of both, and below that 325, which is P1 plus P2 is there, we can find out Z bar. So Z bar is coming out as 3.215 meter above the base. So total pressure force will act in the almost center of both, or we can say 3.215 from base. This blue line is showing the total force in the retaining wall. Let us move to next problem, which is a retaining wall has a smooth vertical back which has to retain a sand backfill. So we are discussing cohesion less soil. Having height 8 meter, a uniform surcharge of 20 kilonewton per meter square is placed over the backfill. It is given by backfill. The water table is 4 meter below the ground level, so water level is halfway. The specific gravity and void ratio are given 2.6, 0.76. The degree of saturation is also given. The angle of friction is 530, both above and below water table. Draw pressure distribution diagram and determine magnitude and the point of application of resultant active thrust. So which we have found out in the previous problem, we have to do the same process, but the case is somewhat different. Let us understand through this. Here three things are given: G, E and SR. G specific gravity, E void ratio and SR. So we have to remember chapter number 3, index properties of the soil. From that we can calculate unit weight. We have to find unit weight from these three values. Let us understand this problem through figure. Here 8-meter retaining wall is given, surcharge is there, as well as water table is halfway of the retaining wall. So in the upper half there will be no moisture, and in the lower half there will be submerged soil. So we have to calculate like this. Here I have shown surcharge, one rectangle we can see that is due to surcharge, and upper triangle we can see with a green arrow which is due to upper half of the soil. And for bottom half of the soil we have to calculate two triangles which are shown by orange and lavender arrows. Let us calculate this through basic unit weight. Now for unit weight we will use formula gamma is equal to gamma B is equal to G plus E into SR, all in bracket, into gamma W upon 1 plus E. G, SR and E are given. Gamma W is by default 9.81. Let us take gamma as 15.55 kilonewton per meter cube. So this is my unit weight. This is bulk unit weight. I have to find saturated unit weight as well as submerged unit weight. For saturated unit weight, G plus E into gamma W upon 1 plus E. These formulas are used in chapter number 3, index properties, relationships and tests of this GT subject. Here G and E are given, gamma W is by default, so gamma saturated will be 18.73 kilonewton per meter cube. Now the third thing will be gamma dash, gamma submerged. Gamma submerged will be gamma saturated minus gamma W, and gamma dash will be 8.92 kilonewton per meter cube. So we got all three unit weights. Now we can begin calculations from part 1 to part 5. Phi is also given, so we can find out Ka also. Here we are discussing only about active earth pressure, that is why we are only finding Ka. From phi we can find out K as 1 by 3. Now for the first part, this red arrow, or we can say due to surcharge, P1 pressure due to surcharge. Let us calculate that. So P1 will be K into Q, as we have understood previously. Now K is 1 by 3, Q is given, P1 will be 6.66 kilonewton per meter square. Now this is first pressure. If we want to find out pressure force due to P1, then capital P1 will be, as it is a rectangular diagram, so base into height. So base is 6.66 and height is 8 meter. So P1 will be 53.28 kilonewton per meter. Where it will act? It will act at the center of the rectangle, and it is 4 meter from base of the wall. Let us move further for P2. So P2, pressure due to dry soil. Now due to dry backfill, or we can say upper half triangle, can be calculated as P2 is equal to Ka into gamma into H1. So we did the whole process in parts, so it will be easy. Let us take part 2, P2, as K into gamma into H1. Now K is already been find out, gamma we know that, and H1 is 4 meter. So P2 will be here 20.73 kilonewton per meter square. Now P2 force will be 1/2 base into height of the triangle. This triangle is having height 4 meter and base is pressure 2. So P2 force will be 41.46 kilonewton per meter. Where it will act? It will act at the CG of the triangle. And where will be the CG? Above 4 meter, that is definite, because it is upper half of the triangle, so it must be above 4 meter, but where? So we have to calculate 4 plus. If we calculate it from base, 4 meter height, so it is in center plus what height? 1/3 of the total 4. So it will be from base 5.33 meter away. So this is all about P2. Now the P2 force, P2 pressure will act from upper half. The same will be continued in the bottom half as a rectangle also. For that rectangle, I am calculating it as an individual force. So P3 pressure will be same 20.73, but height will be 4 meter and it is in a rectangular shape. So we have to calculate P3 force as 20.73 into 4 base into height only. Then it will come as 82.92 kilonewton per meter and it will act at the center of the rectangle at 4 meter. So this is shown by black arrow. Moving forward to item number 4, P4. P4 is pressure due to submerged soil. So we are coming to the bottom half of the soil. So it is governed by two triangles. Right. For that two triangle, we can calculate pressure as P4 is equal to K into gamma dash into H2 as 11.89 kilonewton per meter square. P4 force. If you want to find out pressure force by this orange arrow, or we can say due to submerged soil only. So it will be 1/2 base into height. Base will be our pressure and height is given as 4 meter because water table is at 4 meter only. So P4 force is coming as 23.78 kilonewton per meter and it will act at the CG of the triangle. Which triangle? This orange arrow triangle, and it will be 1/3 of force. So 1/3 of 4 will be 1.33 meter. So let us move to last triangle which is governed by water. Pressure due to submerged soil, but in that due to water. So P5 will be gamma W into H2. Now gamma W is 9.81, H2 is 4 meter. So pressure due to water will be 39.24 kilonewton per meter square. And pressure force due to that will be 1/2 base into height. So base will be our pressure and height will be 4 meter. So P5 force will be 78.48 kilonewton per meter. Now where it will act? Again it will act at the same height, 1/3 of 4, that will be 1.33 meter. So we got all the arrow forces and locations of arrows, but still we want to find out resultant total force and its location. Let us move towards that. Total active thrust. So P force will be P1 plus P2 plus P5, like that. Total force will be 279.92 kilonewton per meter. And now the total active thrust will act at where? We have to calculate through mean, or we can say average of all say P1, P2, P3, P4 and P5. So doing average for that, we will do like this: force 1 into height 1, force 2 height 2, force 3 height 3, like that. And in denominator we will put total force, as Z bar is coming 2.62 meter from base. So the pressure will act at 2.62 meter from base. So it will act at, we can say, roughly 1/4 height of the retaining wall. So that's it for this lecture. We will continue in the next lecture the same topic. Thank you.